All right, so today's ed puzzle is going to be a little shorter just because I've been making you guys do long ones recently, and we're going to be talking about variations and adaptations. Now we've been talking about a lot of environmental things. We're going to go a little bit more into specifically populations and characteristics of populations today. So, as you can see, we have our agenda, which means you have to first do your attendance form. So if you haven't done that yet, pause this and then go do your attendance form. Second is going to be this ed puzzle on variations and adaptations. And then you're going to work on your interactive journal. If you're a B day, you're going to be working on section 1. And if you're an A day, you're going to be finishing up section 3 and turning in your interactive journal after this. Lastly, you have an exit ticket before you leave the Google Meets today. Make sure you get that done in the correct order so that you get the best possible score you can on your exit ticket. Our do now. Give your own example of a characteristic found on an animal that helps them survive in their environment. The example I thought of that you guys shouldn't be copying, so try to think of a different one, is that tigers have stripes, right? And that helps them blend into tall grasses when they hunt for prey, because their stripes look like the same patterns as grasses when they're moving and swaying in the wind. So that's also called camouflage, right? So that is an adaptation that tigers have that help them survive in their environments. So think of one of your own and write it out for me. All right, so our learning objective is that students will be able to identify the relationship between physiological, anatomical, and or behavioral adaptations to their environments. So first of all, we got to establish that populations have variation. Now, think about this real quick. We're going to go through these 3 questions together. Does every human look identical or the exact same? The answer is no, right? I look different from you. Y'all look different from each other. You also even look different from the people in your family. You might look more similar to them, but you're still different, right? You have different characteristics. And there are people who have lighter skin, darker skin. There are people who are taller, who are shorter. There are people who have straight hair, who have curly hair. There are people who have longer hair, shorter hair. There are people who have more facial hair and less facial hair. There are people who have different proportions of their bodies, right? Some people have longer arms, some people have longer torsos than other people. And so no, not all humans look identical, which means that we have variation, okay? Another example that's easy to think about is, do all dogs look alike? Again, the answer is no, right? You have dogs like Chihuahuas, and then you have dogs like Great Danes that are massive, right? So they differ like in size. Some have pointy ears, some have flopped ears, some have patches, some have only one color, some have blue eyes or multicolored eyes, and some only have brown eyes, right? So almost all dogs look different, but they're all the same species, right? You can interbreed dogs even if they look different because they're all the same species. So there is a lot of variation within dogs, right? From size to coloration to eye color to even just behavioral, right? So dogs have variation too. What we're getting at is that most of life has variation. Another thing that you can think about that is a little bit less obvious from the surface level is, does everybody get sick the exact same time from the exact same infection? Now, this question is a little bit weird to think about because right now coronavirus is going around, but there are such things as carriers, right? Because some people don't actually get sick and show symptoms, right? Some people's immune systems are stronger than other people's, and that's genetic, right? That's a variation. People have different immune systems, and having different immune systems means that some people are better at resisting viruses, and some people are worse at resisting viruses. So the people who are worse get sick more often. People who are better are the ones who are like, yo, they never get sick. They're always healthy because there's variations even in things that you cannot see with your eyes. For example, your immune systems. Okay. So variation is defined as the differences between individuals within a species caused by genetic or environmental factors. Now, we say environmental because sometimes you look different just because, like, for example, haircuts, right? That's not genetic. Your haircut is an environmental factor. You felt like doing something, so you did it. You got it cut a certain way, and now you look different from somebody else who maybe you used to have the same haircut as. Variation is also genetically caused, like the way that you look, the way that your facial structure is, the way how tall you are. Those things are genetic, and those are different within a whole species, right? Not every human looks the same. Not every human is the same height. We can also specifically talk about populations, right? Even in just like, for example, our classroom, not everybody is going to be the same height. So you can just take a smaller group instead of the entire species, right? We're not going to talk about all the humans on the earth because then we'd have to poll everybody and figure out how tall everybody is. But you can even just look at a smaller group like our class of people, and you can already see that there's differences or variation in factors like height, eye color, hair length, right? So having differences in a population is beneficial. These differences are a result of adaptations, and we'll talk about adaptations next. The reason it's beneficial is because if every single population was identical throughout their population, then if like a disease struck, then everybody who has the same immune system who's weak to this disease is going to die out and the whole population will get wiped out in an area, right? That's not great for survival. So having differences mean that some people are better at surviving things and some people are worse at surviving things. But maybe the people who are worse at surviving this disease are better at surviving based on their ability to hunt for food in an area. So there's ups and downs and there are trade-offs, right? So if you're good at one thing, you might not be as good at another thing. But having these differences is beneficial for the population overall to survive and get more and more fit and survive in the environment even as it changes. So what is an adaptation? Google says, an adaptation is a change or the process of change by which an organism or species becomes better suited to its environment. So when organisms are slowly over time as a species adapting to their environment, it means that as the environment changes, the ones that best fit or best at surviving in that environment are the ones that do survive and make babies that are like them. And then their babies are also good at surviving in the environment because their parents were good at it. Okay, but when the environment changes, then maybe it shifts towards a different group within a species or within a population that better fit the new environment, right? So remember, organisms cannot adapt. Organisms yourselves, your genes don't change enough for you to have an adaptation within your lifetime, okay? Even just a couple having kids, that's not adaptation. Adaptations don't occur in small groups. They occur in large populations or in a species overall, okay? Adaptations are also slow. They can take hundreds or even thousands of years to develop any differences. So over 1,000 of years, you can look back in history and look at humans, and there are a lot of things that are different. For example, immune systems are different. People used to get sick from diseases that now they wouldn't get sick from. And then people back then, if you let them time travel into current day situations, we have brand new diseases that would totally wipe them out, but we are resistant to them and we are fine, right? So things like that are pretty interesting where adaptations take a long time to develop. So they're not just going to happen overnight and all of a sudden you're going to be like, I'm the best fit for this environment. No, it's over a long time where like natural selection causes the weaker ones to die off and only the stronger survive. So the stronger ones have kids, and then the kids are also have the strong characteristics for living in the environment. So there are 3 categories of adaptation. So the first one is called a physiological adaptation. If you need to repeat after me, physiological. Okay, so a physiological adaptation is a physical but reversible change that helps an organism survive in an environment. So an example that we see in humans is getting tan. As you can see in this picture, this dude was wearing a shirt and he was outside, so he's getting tan, right? But the part that was covered by his shirt is not getting tan. If you get tan, say in the summer, because you're playing outside, you're playing sports, and then over the winter, as you don't get as much sun exposure, what happens to the part of you that was tan? It fades, right? So your skin naturally reverts back to its original color when it doesn't get more exposure to the sun and constant exposure to the sun. So it's a reversible process. It is a physiological adaptation. And the reason why it is a beneficial adaptation is because when your skin is more tan, it's better at blocking harmful UV rays from the sun. And you're less likely to get skin cancer because you're less likely to get sunburn and sun damage when you have more melanin present in your skin. Okay. Another example that is kind of funny to think about is when your fingers get wrinkly from being underwater for too long. Okay, so when you are in a pool for like an hour and you're just swimming around, playing and chilling, and you notice that your fingers are wrinkly, that's actually an adaptation for making it easier to grip things underwater, right? The more texture on your hands versus the normal smooth surface under the water where everything's already slippery makes it easier to grab onto things in case you need to hold on to something. And when you get back out of the water after a while, your fingers may still look a little pruny, but eventually they revert back. So it is reversible. One other one that is pretty cool, if you've ever lifted weights or you've ever done repeated motions of something, right? So people who play sports tend to also get calluses, even if they're not lifting weights. Or if you do construction and you work with tools and you tend to rub the same parts on your hands, you get calluses on your feet from walking in shoes that don't fit the best, right? So the constant rubbing on a surface of your skin, usually on your hands and your feet, will cause harder patches of skin to form, right? I have patches on my hands from lifting weights up here. And honestly, if I don't lift weights for a while, they peel off after a little bit, and then I don't have calluses and my hands are back to being soft, right? So calluses are reversible because if you don't keep on wear and tearing on the area that you always cause wear and tear on where the calluses grew, then the calluses will eventually go away. So it is a reversible process. If you can, I want you to try to think of something. It doesn't have to be in humans, it can be in animals, of a reversible process that is an adaptation that helps an organism survive in an environment. Write it down. If you need to, you can actually look one up, but phrase it in your own words. Okay, the next one we're going to talk about is an anatomical adaptation. Now, people get these confused a lot with physiological adaptations, and I'm going to emphasize the biggest difference between them. So an anatomical adaptation is a physical trait that an organism is born with that helps it survive in its environment. So it's not one that is reversible. It's also a physical trait, but it's not reversible. You're born this way and you are this way, and that is it. But you are born with this adaptation and it helps you survive. Okay, so the example was the one that I said earlier with tigers having stripes, right? The stripes help them blend in with the grass, so it helps them hunt and catch their prey better, right? They're born with stripes though. They don't just have stripes some times of the year and then sometimes they don't, right? They are born with stripes. Another example is giraffes. They have really, really long necks so they can reach the nice juicy leaves at the top of the tree and not have to compete with other organisms for food in the lower part of the tree, right? They are born with the long necks that they have that let them reach that food more easily. They're not born and their neck shrinks or grows depending on what time of the year it is, right? They're born like this. Other ones are like the streamlined body shape of a fish. Fish actually swim a lot faster in the water than humans do, not only because their muscles are built differently, but because their body shape is like a little torpedo. And they shoot through the water super quick because it has less drag on their body. The water doesn't catch as much on their body because it's very smooth and rounded with a pointed end to help them break the water pressure and go through it. The coolest one, I think, right here with my picture paired with it is having birds having light bones. So if you look at the normal human bone over here, there's bone marrow, which makes a human bone really heavy. And then the bone is really dense and there's only really, really small air pockets inside of the bone because it allows your bones to bend a little bit and be compressed a little bit without breaking. Now, if you look at the bones of a bird, they have giant air pockets in them. Like bird bones are literally hollow compared to human bones. And that's because they do what? Yeah, birds fly, right? You want to be lighter when you're flying. So their bones have adapted over time to become lighter and lighter and lighter to let the birds fly more easily without as much effort, without using as much energy, and because taking off is important. If you can't take off fast, then you're going to become food for a predator. Behavioral adaptations are the third kind of adaptation that we're going to talk about. So behavioral adaptations are actions or behaviors of an organism that helps it better survive in its environment. So these are actions. So they're not going to be like confused with the other ones because a behavior is something you do, right? Anatomy is something you're born with, and then physiology is something that is physical but reversible. So behavioral adaptations, for example, are like migration. When it gets too cold in a place, animals like over here, like Canadian geese, will fly to warmer areas than their habitat in the winter when it's too cold in Canada, right? We see Canadian geese in the US a lot because they're flying south from Canada to hang out with us in their winter because it's really cold in Canada. It's less cold here, but they're not interested in going somewhere warm. They just want somewhere less cold. So they migrate in the winter from Canada over to the US where it's warmer and they have food because in Canada, when it gets too cold, their food sources are also going to disappear. Hibernation is the second good one, where bears, for example, in the fall, they start storing a lot of fat on their bodies by eating a lot of fish and a lot of berries and a lot of other things that help them build up their body fat because when it gets really cold, instead of wasting energy walking around trying to find food where there's not a lot of food available because it's cold, they can then go for a long-term sleep using that stored fat. And that is something that their body hormones tell them that, oh, the weather is changing, the days are getting shorter, it's time to get ready to hibernate. And it's a behavior that they do to help them survive better because they're not wasting energy, and then they're more likely to survive a winter if they're hibernating instead of trying to hunt for food where there's no food available. A shorter term one that's a behavior is a puffer fish. If you've ever seen a puffer fish, you know, first of all, that in Japanese cuisine, people eat them, and it's really, really toxic if it gets prepared wrong. But this same puffer fish, when you scare it in the water or when you're a predator trying to eat it, it will actually puff up with water or puff up with air, depending on where it is, as a defense mechanism so it cannot be swallowed. Now, the puffer fish isn't permanently stuck like this either, right? It's going to revert back to its normal shape after it's done showing off this threatening behavior, right? It does this on purpose. It's a behavior that it does to prevent itself from getting eaten, right? And it helps it survive better in its environment. So if you can, think of an example of a behavioral adaptation. If you really can't, you can look one up and make sure you phrase it in your own words. All right, that is all for today's Edpuzzle. It's not that long. Make sure you go and do your interactive journal. Again, if you're doing this on an A day, you're finishing your interactive journal, turning it in. If you're doing this on a B day, finish section 1, and then just leave the interactive journal to go do your exit ticket app.